Make sure our sound is working. Oh. Testing. Input volume is working. Yes. And that was what I needed to test there. I know the speaker. Okay. All right. Okay. Now, here we go. All right, welcome to our lesson on mixed strategies. This is going to be a little more challenging in some ways than what you've been learning. There is some simple math involved in it, nothing too complex, but you're going to be dealing with more complex situations. In this scenario, we have to recognize that there are several key elements. So let me bring up a PowerPoint so we can go over these. So as you can see, there are three key aspects of the game that are necessary in order for you to have a mixed strategy. The first is there must be simultaneous play. In other words, both parties have to make their decision at the same time. If you don't, if it's not simultaneous, if the play is not simultaneous, then the other player can simply wait until you've made your choice, then make whatever choice is most advantageous for them. But in a simultaneous game, let's say something like a soccer kick, the goalie and the kicker have to make their decisions without being able to get the other one to fully commit. And that means they have to make their decision simultaneously. It would be the same thing in a tennis match when one of the players hits down the line or cross court. The second aspect is repeated play. It means you're not going to just play one time, but you're going to be playing this on a repeated basis. You're going to be kicking on goals many, many times during the game, during the season. And finally, that there's a zero-sum payoff in each case, meaning that if I win, you lose. So, you know, we need to consider that with each move. So let's talk about a mixed strategy. Let's talk about a soccer kick. Now, in the case of a soccer kick, you have the goalie and you have the kicker. You have two different situations, but the kicker has to make the decision. Should they kick left or should they kick right? Now, the goalie, he can sit there in the middle, but at some point wants to make a decision. Should he cover more of the left side of the goal or more of the right side of the goal? What's going to be most advantageous? So here I put together a mixed strategy game. Player one is the kicker. Player two is the goalie. Now in this scenario, if player one kicks left, and if the goalie determines that I'm going to kick left, then I have a 30% chance of scoring, and he has a 70% chance of blocking my kick. On the other hand, if I choose to kick right, and he picks left, if I pick right and he picks left, I have a 70% chance of making the goal, and he has a 30% chance of defeating me. You might ask, how is that possible when he's not there to block it? Well, I may not be the best kicker in the world. I might miss, right? It's possible. And maybe kicking right's hard for me. So let's go up to the other situation. If the player kicks left and the goalie guesses right, I must be a better kicker at kicking left because I have a 90% chance of winning and a 10% chance of losing. But if I kick right and they guess right, I have a 40% chance of winning and a 60% chance of losing. So there's my normal form, which is what you're normally going to be working with. And I have given you the equation. So this is the equation for mixed strategy. You have to memorize it. You need to memorize it. It's really quite simple. EP stands for expected payoff. What is my expected payoff with my mixed strategy? And it's equal to the probability, P, times the top left score. So this is for me as the kicker. That would be 30, right? Plus 1 minus P times the bottom left, that would be 70. Now you're probably wondering, well, but Dr. Thomas, what are P and Q? Well, that's what we're trying to calculate. The probabilities, right? So let's leave that till later. So it's 1 minus the probability times the bottom left. All of that times Q, which is the probability of the other player if they choose left, plus the probability times top right plus 1 minus P bottom right, all of that times 1 minus Q. So if you haven't guessed already, my top left is P and my bottom right is 1 minus P. And the other player's Q is their left and their 1 minus Q is the right. So let's go through and solve this equation. The first thing that we have to do is put the payoffs in. So now it becomes P30 plus 1 minus P times 70 times Q plus P90 plus 1 minus P times 40 times 1 minus Q. Now if we multiply this out, we get 30P plus 70 minus 70P times Q plus 90P plus 40 minus 40P times 1 minus Q. And then if we do it further by multiplying the Q's and 1 minus Q's, we get 30PQ plus 70Q minus 70PQ plus 90P plus 40 minus 40P minus 90PQ minus 40Q plus 40PQ. Now, obviously, there's lots of P's and Q's and lots of Q's and P's. So what we're going to do is combine those so that all the P's and Q's, the PQs are put together, all the Q's are put together, and all the P's are put together. And we end up with this. My expected payoff is minus 90PQ plus 30Q plus 50P plus 40. Now, we have to solve for P and Q. And I have good news. I've already taught you more than enough calculus to solve this very, very easily. Now, here's another form you can use for writing a first order derivative. So F prime P is first order derivative of P. And I'm going to slide over here now and get out of the way. Okay, so F prime P equals minus 90Q plus 50 equals 0. Remember, there's a P in here. So the minus 90 becomes minus 90Q. No P, the 50P becomes plus 50. We don't do the 40, that equals 0. If we have then do the Q, F prime Q, it's going to equal the same minus 90 times P this time, plus the 30Q at 30 equals 0. Now, you can probably see how easy this is to solve, but let's go ahead and do it. So F prime P equals 90Q equals 50. F prime Q equals 90P equals 30. So what do? We solve for P and for Q, and we get Q equals 5/9 or 55.56%. And P equals 1/3 or 33.34%. So what do we do with that? Well, we want to know what is the probabilities I'm going to win if I use a mixed strategy. And remember, I told you P is top left for P1, and P1 minus P is bottom right for P1. And let's go ahead and write these in now, okay, so you can see where they go. So what do? My best strategy is to kick, if I'm the goalie, my best strategy if I'm the kicker is to kick left 1/3 of the time. And that means how often do I kick right? 2/3. And if I'm the goalie, I should block left 55.56% of the time and block right 44.44% of the time. Roughly 50/50. That is the optimal strategy. If either player deviates from those percentages, their likelihood, and the other one, if either player deviates from these percentages, and the other player does not, then that player that deviated will get a lower score and is less likely to win. And so this is how we solve mixed strategy problems. It's not that hard. You need to memorize the formula, and you're going to do that by practicing it. And very, very useful formula. You should know it. And then I'm going to give you some homework with a couple of these to solve, and then you can turn those in and we can go over that. But it's a very simple approach. And one of the cool things about normal form is if you solve it first, like we normally do, you'll find out something very interesting. So let's take a look at this particular game. If we solve this in terms of single play, if player 2 chooses left, player 1 will choose right. And if player 2 chooses right, player 1 will choose left. Now, if player 1 chooses left, player 2 will choose left. And if player 1 chooses right, player 2 will choose right. Guess what? There is no pure strategy Nash equilibrium. It's not surprising. And so we consider 0 an even number, as well as 2 and 4 and so forth. Anytime you have an even number of pure strategy Nash equilibrium, then you need a mixed strategy solution. That's just a rule, and you can count on it. So when I give you an assignment and I ask you, is there a mixed strategy? Very simple solution. Solve it and see if it's an even number. And then you'll know whether or not you want to use a mixed strategy. And of course, then I'll say, and if there is, solve it. Tell me what the best option is. So you've got both players' best strategies calculated. And the thing is, you have to make sure that when you implement the strategy, it's done with full random functionality. That means, if yes, I'm going to kick left 1/3 of the time. But I can't just do it 3 times and then kick right 6 times and then left 3 times. I can't have a pattern. As soon as I have a pattern, their team will figure that out, and then they'll beat me. But on the other hand, if I have a computer that generates a random number, where 1/3 of the time it picks the number for left, and 2/3 of the time it picks the number for right, then they can't do that. And this is how it's done during a game. Somebody on the sideline has all these calculated, punches a number, and tells them kick left or kick right, and that's it. So welcome to mixed strategy.